Hello everybody. There are some questions about Lagrange multiplier and optimization and how it works. So in this small session or short session, I'm trying to explain a little bit about how to use Lagrange multiplier in solving some optimization problems. So yes, let me just maximize this one. Yeah. So here I will start by simply assume or solve some simple problem to see how to solve optimization problems with Lagrange multiplier. Okay, let us select this very simple basic problem that you have a circle which has radius r, and this radius is at 0 0 at the origin. Okay, and we want to find, for example, if we have another point at x0 and y0, we like to find the minimum distance between this point and the point on the circle. It means that what is the point here? If we call this point like x and y, what is x and y, which will have the minimum distance with this point x0 and y0. As you can see, this point can be larger to this one, or even larger to this one, or it can be to this point. It can be anywhere. So we are looking to x and y, which will have the minimum distance between the circle, okay, and the point x0 and y0. Okay, now we know that this distance d could be calculated as d equal to square root of x minus x0 square plus y minus y0 square. This will be the distance d. Okay, and of course this point should be on the surface of this circle, which means that we want to minimize this distance d, but we want the point to be on the circle, which means that the equation of the circle, and as it is at the origin, it will be x squared plus y squared, okay, equal to r squared. R is the radius of the circle. Okay, now minimizing d is the same as minimizing d squared. Okay, then we can make it like the equation, like minimize x minus x0 squared plus y minus y0 squared, subject to, we have the constraint now, that x squared plus y squared equal to r squared. So now this is the constraint optimization problem. This equation is like straightforward and simple equation that can be solved with the Lagrange multiplier. But remember here that we have equality constraint, not inequality. We will see in the second example one inequality constraint problem. Now, solving this one, we can build the primary form of the unconstrained cost function. It can be like LB, the primary form, equal to x minus x0 square plus y minus y0 square plus lambda is the Lagrange multiplier times x square plus y square minus r square. We can find the optimum like points by partially differentiating this equation, this L with x and y and lambda. So we have the derivative of LB with x. This will be 2 times x minus x0. Okay, differentiating this with x will be 0, and plus 2x times lambda equal to 0, and also differentiating LB with y, it will be quite the same, 2 y minus y0 plus 2y lambda equal to 0. And finally, we have the constraint itself, which is that x squared plus y squared equal to r squared. Okay, so now we have three equations into three unknowns, because we have the unknowns x and y and lambda. We can, by looking to this 1 and 2, we can easily find that, because we can cancel 2 from both equations. Okay, then we can say that from equation 1, that lambda equal to or actually we can calculate based on x, so it would be better. So if we calculate with respect to x, or compute with respect to x, let me remove this. Okay, so it becomes easier. So we can find what is x now. So x now as a function in lambda equal to lambda, as you can see, because now 2 is, we can take 2 as a common with 0, and then we have x minus x0. We can put x0 on the other side, it becomes x0. Okay, and then we can take x as a common, so it becomes 1 plus lambda. So we have here x0 over 1 plus lambda. You can easily find this from equation 1. And from equation 2, we have also the same. We have y equal to y0 divided by 1 plus lambda, the same. Okay, and now we can substitute this part and this equation into the third equation. We will have here like x0 squared divided by 1 plus lambda squared plus actually it will be the same, also 1 plus lambda squared, and above will be y squared. Then we say just plus y0 squared equal to r squared, and then we can easily find what is 1 plus lambda. So 1 plus lambda equal to x0 squared plus y0 squared, and the square root divided by r, and of course don't forget to put a plus or minus, because this could be plus or minus. Okay, now what is x? We can easily now find x. So the optimum x which achieve the minimum distance will be this is 1 plus lambda. Okay, so it will be like x0 times r divided by square root x0 squared plus y0 squared plus or minus, and also y equal to plus or minus y0 times r divided by x0 squared plus y0 squared. Okay, so this is the solution. Should we select plus or minus? Actually, you can substitute when you have certain specific number. You can substitute with these values into the equation of the distance here. Okay, then you select the smaller distance. Let us take example, a numerical example. Okay, assume now the r, this circle which is at the origin 0 and 0, and let us assume that r equal to 1. Okay, and let us take any x0 and y0. So it might be like x0 and y0. It can be for example, say any number, maybe 2 and 3, for example. Okay, how to find x and y on the circle which has the minimum distance with this point? So x will be that plus or minus x0 is 2, okay, times r, the radius is 1, is 2, then divided by square root 4 plus 9. 4 plus 9 is 13. Okay, and y will be also, this will be y0 is 3 divided by square root of 13. So this will be x and y. Of course it is plus or minus. Okay, and now if you want to take which point will be, is it the plus or minus? You can substitute this in the distance, in the equation of the real distance, or distance squared is the same. So distance squared equal to, we said that it is x minus x0 squared plus y minus y0 squared. Okay, now this equal to, if you substitute with this x, so it will be 2 divided by square root of 13. Okay, this is x, and x0 is 2, so it will be like 2 divided by square root of 13 minus 2 square. Okay, and plus y is 3 divided by square root of 13 minus y, sorry, this is square outside, so minus y0 is 3 divided by of the power of square. Okay, now you can compute this one, and you can try with the negative sign. So in the negative sign, d square, this is 1, for example, 2 is equal to 2 divided by square root of 13, but this will be like minus, so it becomes minus 2 square plus minus 3 over square root of 13 minus 3 square. It is very clear that this d2 will be greater than d1, because this number will be larger, and when you take the negative square, it will be both, it will be larger than d1. Then the minimum distance that you can take for this example, that x equal to 2 divided by square root of 13 and y equal to like 3 divided by square root of 13. So it is simply like that. So now you can find the distance between any point on this with the minimum distance where it will project it. For example, if it is here, the point, so what is x and y on the surface of the circle, which will have the minimum distance with this point. So now we found it simply by using the Lagrange multiplier in optimization. This is for the constraint optimization, and in the second, with equality, in the second case we will see how to solve them with inequality. Remember that in equality case, we don't care what is the value of lambda, is it positive or negative. This lambda, it can be any value, actually it can be any value, there is no problem. But in inequality case, we will see that if lambda will determine that if it is active constraint or inactive constraint. In case that it is inactive constraint, then we should set lambda equal to 0, then to remove that constraint, because it is inactive constraint. In case of active constraint, we should keep lambda, and this is what we explain in the second example. I hope that this example is simple enough to understand how to apply Lagrange multiplier. Thank you.